Okay, let's give you guys some practice. So here, find dy by dt. Okay, so yeah, so differentiate this. Find dy by dt. So press pause and have a go. Okay, so to do this here, visualize it as one block multiplying with another block here. So you've got to use the product rule. Remember, the product rule is differentiate this, leave this the same, and then leave this the same, and then differentiate this. Okay, and when you come to differentiate this, you've got to use the chain rule. Okay, so well, anyway, differentiate this. It will give you so visualize this as one block multiplying another. So the first step is differentiate this, leave this the same. So when you differentiate this, it will give you a 3. You leave this the same, giving you this here. Okay, and then the next step is to leave this the same and then differentiate this. So leave this the same and then differentiate this. And here you've got to. So when you differentiate this, it will be. So here you've got. When you come to differentiate this, it will be 2 and then to the power of 1. But then you've got to use the chain rule. You've got to times it with the differential of this thing here, which is 1 over t. Okay, so when you come to differentiate this, it will then give you this. Okay, now it's just a matter of tidying up. So yeah, so tidy this whole thing up. It will give you this, and this remains the same. And then so given y equals this, dy by dx. Sorry, dy by dt. Hang on, sorry. Dy by dt here. Yeah, dy by dt equals that. So get yourself a graph plotter. So dy by dt equals this here. So now get yourself a graph plotter and plot the graph. You see, this is your normal y here. So hang on. So y was this. Y was 3t times the natural log of t squared. So y is this here. So when you get a graph plotter and plot y equals that thing there, it will then give you this. Okay. Now get yourself a graph plotter and plot this here. Well, change this to a y, and then try and plot this graph here. It will give you this. Hang on. It will give you this. So now looking at this, you can have a quick check of your answer. So looking at the red line, you see here it's positive, 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 up to this point here. Now looking at the derivative, you see it's positive, 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 and it's 0 here. The derivative is 0. Looking at the red line here, the derivative right here will be 0. So it kind of makes sense. And then looking from here, negative, 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 0 here. Looking at the blue line, it's negative, 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 and 0 here. And looking at the red line, it's positive, 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 positive. Looking at the blue line, positive, and so on. Okay, so it does kind of make sense. So it's just a way of you checking your answer. So it's not perfect, but it gives you an indication. If you make some silly mistakes, you're going to get the derivative line looking, I don't know, maybe something like this. Then you know there's something fishy going on. Okay. Well, anyway, here's the next one. So differentiate this. Now differentiate dy. Find dy by dx. Okay. So press pause and have a go. Okay, so to do this here, visualize this as to the power of a half. So square root is the same as to the power of a half. So now you've got one block times with another block here. So you've got to use the product rule here. So differentiate this. So using the product rule, differentiate this, leave this the same. That will then give you this. And then leave this the same, and then differentiate the whole lot. Differentiating the whole lot will give you this. Okay, because you've got to use the chain rule here. When you differentiate this thing goes down, so that will give you a half here, and then leave this whole thing intact. You leaving this whole thing intact, and then the power gets minus by 1, and then you've got to times the differential of this. So it's you using the chain rule here. So when you differentiate the bubble here, it will give you 1 over this thing here. Okay, and then you've got a bubble within a bubble, so you've got to times it by the differential of the inner bubble here, which is 2. Okay, so now tidy up the whole thing. Well, this thing here will take you to here, and again tidy that up. That will then give you this. Okay. Well, power of a minus a half. That's the same as this. Remember from our section on indices, if you have to the power of minus a half, that's the same as 1 over x to the power of a half, which is 1 over square root and so on here. So my point here, tidy this up, it will give you this. Okay, and then we'll again tidy it up again, it will then give you this. Now get yourself a graph plotter and check your answer. So if you if you look at the red line here, that's our original y equals blah blah blah. Okay. Now looking at the blue line, that's our derivative. So if you get a graph plotter and change this to a y, so y equals blah 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 here into your graph plotter, it will then give you this blue line. Now so the blue line is your derivative of the red line here. Okay. So have a quick check. If you look at this, the gradient here is quite constant. It's quite constant. Okay. So it's hovering along this thing here. So it's quite constant. The derivative is quite constant. But looking at this here, you might think there's something fishy going on. But then yeah, if you look at the derivative, it's really steep here. But then if you look at the red line, it seems like as if it's straight. So it should be constant. But yet you've got something here that's really, really steep. You see, if you investigate further, if you zoom into this bit here, you can see that it's actually kind of a curve. It's kind of a curve like this. Now, it's kind of a curve like this. So you can see that it's really steep here. Well, get yourself a graph plotter and try. If you zoom into this bit here, you can see that it's a kind of curve, giving you the gradient that's really steep. So really, it looks fishy when you first glance at it, but if you zoom into this bit here, it kind of makes sense. Okay, so we're going to say the derivative here seems to be correct. Okay, so dy by dx is given by this.